Newton's laws of motion. Let's consider the first law of motion. Students, let's see this animation and let's observe what Newton's law of motion is. Okay, you see, this is the first law. As we can see from the writing, this object is at rest, and if no force is applied onto it, it will stay at rest. But if the force is applied on it, the object starts moving. You see, if they are interacting, then there is the force between them, as we have seen. Now the ball is at rest, students. Unless we apply force on it, the ball will remain at rest. But when the force is applied, or when the ball is kicked by the force, and it will start moving. So how can we define? Now again, let's consider. It comes to rest. How? There should be the force that is acting on the object. What is the force that causes the object to stop here? If the ball is actually coming to rest, the ball is kicked and then start moving. Initially, it was at rest. Then after some time, the ball comes to rest. What is the force that is acting on the ball and what is causing it to come to rest? We have the gravitational force and we have the frictional force that exists between the ball and the surface of the earth. Now the man is cycling, the ball is moving, so they are continuously in motion. When they are at rest, they are continuously at rest. Now we are in position, students, to say something about Newton's first law of motion. You see, we have different explanations, we have different demonstrations. The ball is coming to rest because the gravitational force is also acting on it. So an object which is moving will come to rest when the force is acting on it, and this is explained by the Newton's first law of motion. We can define now inertia. Inertia is the ability of the body to resist or to oppose the change of state of motion. So the forces that can act to change the state of motion can be the gravity and the frictional force or other applied forces. Newton's first law of motion or law of inertia. You see, if you have an object at rest, it will remain at rest unless you apply force on it. As you have seen from the ball is at rest, but when the ball is kicked, it starts moving on the direction indicated. Or when it is moving, when the ball is moving on this line, it will continue moving with the same velocity unless the net force is acting on it. This is how we say or how we understand the Newton's first law of motion. So it's law of inertia, and for the object to change this state of motion or state of rest, then we need what we call the net force. Okay, if the net force on the body is zero, that means there might be forces, but if the sum of all the forces on the body is zero, then the object is either at rest, you see, or it is moving with uniform velocity. What does this mean? There might be forces, but the net force, we are saying, if the net force is zero, if the net force on the body is zero, if we have an object, there might be different forces acting on it. There is a normal force, there is the weight, there is applied force, and there is also frictional force, and so on. Okay, if the summation of all these forces acting on the body is equals to zero, then we have two possibilities. One is the object may be moving with uniform velocity, or the object may be at rest. And this is what we call the Newton's first law of motion. Okay, if the net force on the body is non-zero, or if the net force acting on the body is different from 0, then the body is accelerating, because this force is greater than 0 and it is changing the velocity. When the velocity is changing, then obviously the object is accelerating. Okay, if the body is changing its direction, the one which is moving to the right may change its direction of motion to the left, or the one which is moving upward may have changed its direction to move downward. Then what we can say, there is an acceleration and the net force is non-zero. If there is acceleration, there is force, there is net force, that means. Okay, this is the Newton's first law of motion. Okay, now let's come to the Newton's second law of motion, which we call it as the law of acceleration, and sometimes it is referred to as the basic law of motion in mechanics. Students, now let's see this animation and let's try to understand what Newton's second law is. This is the huge mass placed on the cart and the horse is pulling it, or there should be the force that is applied to it. When the force is applied on an object, the velocity of an object is actually changing, and what we call the momentum, the linear momentum, is produced. And so we can state the Newton's second law that is directly related to mass and acceleration, or we can also say that is rate of change of linear momentum. If there is large mass, we have to apply the large amount of force to accelerate the body or to change the speed of an object. Then this is the big stone, and the child is pushing the stone, or he is pushing the stone. If you are not in position and you have no enough energy, you can't push a big load like this. That means if the mass is large enough, then you have to apply the force which is also large enough so that you can simply accelerate the object, or you can set the object into motion, or you can change the velocity of the object. According to the Newton's second law of motion, which is the law of acceleration, the acceleration of the object A is directly proportional to the net force acting on it. We have the net force F net. Just to show that it is the vector, we can use a vector notation. The acceleration is directly proportional to the net force. This is one way of saying the Newton's second law, and at the same time it is inversely proportional to the mass of an object. If the mass is large enough, we need the large force. During that time, if the mass is large enough, the acceleration is small. So we can write the force as a product of all the forces. This is, the summation. This means the net force. This is, we mean F net. If we have more than one force acting on a body, then the net force is, as we know, the summation of all the forces acting on the body or the system. Then this net force is equals to the product of mass and acceleration, and this is called the Newton's second law of motion. So the acceleration is equals to, if you want to write from the equation, this is F net divided by mass of the object. As you can see from the formula, acceleration is inversely proportional to mass. That means if you have large mass, acceleration will be small. The change of velocity is small. If the mass is small, then the acceleration of the body will be large, so that you can speed up or you can increase the change of velocity of an object of a small mass by applying the force on it. Okay, another way of saying the Newton's second law is that the net force is equals to the rate of change of linear momentum. As you have seen from the animation, you can start from the basic formula, which is m times a, Then acceleration is, we know in uniformly accelerated motion, we know how to write the formula for acceleration. If we have the initial velocity u and the final velocity v in a time t, changed in a time t, this is v minus u over delta t. Substituting this is m times, this is v minus u divided by change of t. You can multiply m times v is m times v like this, and then m times u divided by delta t. But you remember the linear momentum. The linear momentum is the product of mass and the velocity. So this is the momentum final, p final, and this is p initial, the initial momentum of the object. So simply you can write this is p final minus p initial divided by delta t. And the difference between the final and the initial momentum of an object is the change of momentum with time, and we call this Newton's second law. Okay, now let's see an example. There is a block resting on the surface of the earth, and the block has 3 kilograms. The force applied is 45 Newton, and the frictional force is acting in opposite direction. This is the frictional force or the friction force. Now students, calculate the net force acting on the body or on the mass, and then calculate the acceleration of the block also. Welcome back students. Now let's go through this example one by one. Okay, let's assume, because the force is the vector quantity as we said, we have to take care of about the direction. In this case, it is up to us to assign which direction to be positive and which direction to be negative. Let's assume for this example the right direction is to be positive and the left direction is negative. So the force, the 45 Newton force is acting to the right, so that force is taken to be positive, and we have the frictional force which is directed leftward, and we consider this friction as negative when we are calculating the net force. The first is the net force. So from our formula, we know that the net force is the summation of all the forces acting on it. Actually, we are considering on the x direction, and we have also vertically applied forces. We have the weight and we have the normal force. If you add, the net force will be there on the y direction. So we are interested to the net force on the x direction because the motion is along the x direction. So simply we substitute. I made this negative because I assigned the left direction to be negative, and the frictional force is always opposing the direction of motion of the body. Now what is this? We have the net force 27 Newton acting on this body. The second one is the acceleration of the body. Acceleration, as we remember, can be written by using this formula. From the Newton's second law of motion, the net force is equals to the product of mass and acceleration, and we have already calculated the net force, which is 27 Newton or kilogram meter per second square. So acceleration is given by the net force divided by the mass, which is directly 9 meters per second squared. When you divide 27 by 3, it will be 9. Because A is positive here, and we say the positive direction is to the right, so the acceleration of the object or the block is 9 meters per second to the right. Okay, what are the important notes we should have to bear in mind here? If the velocity of the moving object is in the same direction as the net force, then with no doubt it is accelerating. We have the net force and we have the velocity. If the net force and the velocity of an object are in the same direction, then the object is accelerating. It is accelerating. In the second case, if the velocity of an object is, the moving object is opposite in direction to that of the net force, then the object is decelerating. Why? Because the force is applied in opposite direction to the direction of motion of an object, and the velocity is decreasing each second because of the application of force. And in such a case is what we call deceleration. Okay, what about if they are at different angles to each other? For example, if the force and the velocity of an object are acting perpendicular to each other, assume this is the velocity and this is the force, and here we have the object here, then which direction this force is moving? It may decelerate, it may accelerate, but it is in between, and this most of the time follows the circular path. Because the force and the velocity are perpendicular to each other and the object is accelerating, but it is not equals to the case where the force and the velocity are in the same direction. So we should have to take care the direction of the force applied on an object when we are carrying calculations. Now let's consider example 2. It says what average net force is required to accelerate a 5 kilogram block from rest to the final velocity of 54 meters per second in a time of 9 seconds. Okay, students, let you try this problem. Welcome back, students. Now what are the given quantities? We are asked to calculate the average net force, and the given information is that the final velocity of an object is 54 meters per second, the total time taken is 9 seconds, and the mass of the object is 5 kilograms, and the initial velocity of the object is 0 because it starts from rest. So having this information, you can easily calculate the acceleration of the object first. You are asked to calculate the average force, the average net force. But to calculate the average net force, we need the acceleration. So what is acceleration? From the uniformly accelerated motion equations, we know that acceleration can be written as the difference of the final and the initial velocity divided by t. Our final velocity is 54 meters per second, and the initial velocity is 0 meters per second, and the time taken to make change of this velocity is 9 seconds. So the acceleration of the object is 6 meters per second. The net force from the Newton's second law of motion is F net equals to mass times acceleration, and we have the acceleration already we have calculated here, no need of just making here. We have the acceleration, so the net force is equals to mass times acceleration. Mass is 5 kilograms, and we have calculated acceleration is equals to 6 meters per second. Then the product of these two will give us 30 Newton. Okay, this is one of the simplest ways that we apply Newton's second law to mechanics. Okay, let's see another example. Assume a 1,500 kilogram car is moving at the speed of 40 meters per second. So this is the initial velocity, and after traveling some distance, it says it comes to stop after traveling a distance of 200 meters. Calculate the average net force exerted on the object. Students, take time and then find the average force exerted on the brakes of the car. Okay, thank you, students. I hope you have tried to calculate the average force exerted. Now, let's see it together. Okay, there are 4 equations of motion in uniformly accelerated motion, and from the fourth one, we can find the acceleration of the object. You remember this velocity. The final velocity square is equals to the initial velocity square plus 2 times the acceleration times the distance or the displacement covered by the moving body. So from this I can calculate what we call the acceleration. So what is acceleration? From this expression, acceleration is v final square minus v initial square divided by 2 times s. So substituting, because at the end the car stops, so the final velocity is 0, but initially it is moving with 40 meters per second, so we have 40 squared divided by 2 times s, and the distance is equals to 200 meters, and we have 2 from the formula, and you can calculate this to be negative 4 meters per second squared. What does it mean? At each second, this negative shows that at each second the velocity of the body is decreasing by 4 meters per second, so that the acceleration is negative 4 meters per second squared. Now we can calculate the average net force exerted on the object. Okay, simply by using the Newton's second law, the net force acting on an object is given by mass times acceleration. We have the mass already given, which is 1,500 kilogram, which is mass of the car here, and we have calculated the acceleration, which is negative 4 meters per second squared. So the net force is equals to 6,000 Newton. Okay, what is the negative means? The negative means that the force is the retarding force, or the force which is causing the acceleration of the body to be decreased. Okay, students, now let's come to the Newton's third law of motion, which is the law of action and reaction. It states that for every action force there is an equal and opposite reaction force. This is at rest, and if you apply the force on this ball, the ball is also pushing you back, and then if the net force is larger, then it will be set into motion. So, for example, Newton's third law is applicable in everyday life. If you look at this rocket, it is expelling the gas to the ground, and so it is pushing the ground downward, and for that the reaction force will be coming from the ground to the rocket, and this application will help the rocket to be launched and to move to the space. So you remember that the rocket is moving into the space by the application of the Newton's third law of motion. When you are jumping, you are pushing the earth or the surface down, and at the same time when you are jumping up, it is the earth that is pushing you upward. So that means for every action force that is applied, there is an equal and opposite reaction force. Assume you are in a swimming pool. When you are pushing the water in opposite direction, you are moving into opposite direction. This will help you to reach your final destination in your game also. The water, you are pushing the water forward, and as you are coming backward to your destination. So the Newton's third law states that for every action there is an equal and opposite reaction force. That means if you are pushing object 1 and object 2 is also pushing you back with equal amount of force that you applied on it. Okay, further let's see this. Let's consider this example, students. Bona pushes against Haile with a force of 540 newtons directed eastward. We have two students, Bona and Haile. The kilogram of each of them is given, and the force that Bona is pushing against is given 540. From the principle of the Newton's third law of motion, Haile pushes back Bona with the same force that Bona is pushing Haile forward, but the direction is opposite to each other. It asks us, what force does Haile exert on Bona? From the Newton's third law of motion, we can simply answer this. Haile exerts a force of 550 Newton on Bona, but the direction is westward. If this is Haile, or if this is Bona and this is Haile, and if Bona is applying 540 Newton, which is eastward, then Haile is also applying the same force, but the direction is reversed. This is west and this is east. Okay, so this is the concept. Just it is not as such significant, but the meaning, the concept is very important to apply in a more complicated problems also. Okay, another, let's calculate the acceleration for each of them. You remember the acceleration depends upon the mass and the net force. For Bona and for Haile, we have the same force, which is 540. So the acceleration is F net divided by the mass. The net force is 540 and the mass of Bona is 90 kilograms. So the acceleration is 6 meters per second to the west. Sorry students, because Bona is pushing, this has to be east. Okay, this is to the east. And here Haile is pushing back, because we are given here Bona is eastward, so this should be westward. Sorry. Okay, what is the meaning? The same force is applied here. We have 540 Newton, but the mass of each of them is different, 90 for one of them and the other is 60. And so this result is in different accelerations. Okay, if the mass is larger, the acceleration is smaller. If the mass is smaller, the acceleration is relatively larger. That means this will remind us the Newton's second law of motion. For the large mass, the acceleration is small. That acceleration and the mass are inversely proportional. Acceleration is inversely proportional to the mass. Okay, these are some of the examples that we should have to bear in mind. I wrote it as a note. A person with a larger mass experiences a smaller acceleration. Okay, now let's again discuss the Newton's third law, because it is applicable everywhere. Even when birds are flying on the sky, they have to push the air downward, and then by the opposing force from the earth on their wings, they are able to fly on the air. Okay, when we summarize the Newton's third law of motion, that it says that forces always exist in pairs. That means for every action force there is an equal and opposite reaction force. Here we have the action force moving forward, and the reaction force is in the opposite direction. We have two forces here. Okay, it says for every action force there is an equal and opposite reaction force. We have also, we can just see at different examples given on the screen. The sportsman which is swimming is acting in the opposite direction by using his legs, and he is pushing the water backward, and the reaction force that is applied on him is enabling him to move in opposite direction. So if again you consider the weight also, there is the weight and there is the buoyant force which is acting upward. So that means for every action force there is an equal and opposite reaction force. The man is pushing the wall and the wall is pushing the man backward. So for every action force there is an equal and opposite reaction force, which is the elementary concept that we all remember, but the application is very important. What we have to know again is that action and the reaction force act on two different bodies. They act on two different bodies, because when the man is applying the force here, the force is acting on the wall or on the wall of the building. When the wall is applying the force backward, the force is acting on the man. So the two different objects are, here we have the man and here we have the wall. The force of the wall is on the man, if you take this as F2, and the force of the man is on the wall, and if you consider as F1, the two forces F1 and F2 are acting on two different objects, because the man and the wall are completely different. So don't be confused that it seems the same thing, but the two objects are different and the two forces are acting on different objects. Let's consider another example now using the Newton's laws of motion. Given two forces are acting on a 5 kilogram mass, one of the force is 5 Newton south and the other is 15 Newton east. Calculate the magnitude of acceleration. Students, take 2 minutes and calculate the acceleration of the problem displayed on the screen. Welcome back, students. I hope you have tried this problem and it is not challenging. Now let's see the solution together. Now given we have the mass which is 5 kilogram here given, and two forces are applied on the object, but we have to remember the direction. One of the forces is the 10 Newton is to the south and the 15 Newton is to the east. So we have to carefully assign the direction of these two forces in the given on the given screen here. F2 we can say it is south direction, and another force is the, okay, let's change actually this, because the 10 Newton force is to the south, it says, let's say this is east, because it is easy to change this one, and let me say this is south. Now on the diagram indicated, it is appropriate now to carry out the calculation. Let's find the net force. When we want to calculate the net force for these two, we have to use the formula or the principle of vector addition, and the two vectors should be joined in such a way. This is F1 and this is F2. The magnitude or the resultant of the force is what we call the diagonal of the triangle. So how can we find the magnitude of this net force? Because these two are perpendicular to each other and we can use the Pythagoras theorem to calculate the magnitude of the force. So let's assume this is the angle theta between the resultant force and the horizontal force. So the magnitude can be calculated by the Pythagoras theorem, which is F1 squared plus F2 squared. Substituting each of the values, one of the forces is 10 Newton and the other is 15 Newton, and finally if you calculate, it will be about 18.03 Newton. We calculated now the net force. What is the direction? To calculate or to have the direction, you have to find the angle theta. But first, let's calculate the magnitude of acceleration. It is easy because we know the net force and we know the mass of the object. So acceleration is equals to the net force divided by mass of the object, and 18.03 divided by 5 kilograms is 3.6 meters per second squared. The direction of the force is tan inverse of, assume this is F2, so F2 divided by F1. Tan of this angle is opposite over adjacent, so it is correct. This is 15 divided by 10, which is 1.5, and if you calculate, it is 56.4. And when you name this, it is south of east. So how can you write the force with full description or explanation? You can write the force is 18.03 Newton, comma, 56.4 degree south of east. And for the acceleration also, we know the magnitude, and we also have got the direction. It is 3.6 meter per second squared, 56.4 degree south of east. Okay, these are some of the common examples where we can apply the Newton's laws of motion. Okay, now let's summarize, students. We have seen the Newton's laws of motion, and the first law, the second law, and the third law. Okay, what are each of them representing, or what are each of them mean? The first law states that if an object is at rest, it remains at rest. If it is in uniform motion, it will continue moving with constant velocity unless the net force is acting on it. And the other name for the Newton's first law is, as we remember, is the law of inertia. The law of inertia is telling us that if an object has large mass, then its resistance is also large. The Newton's second law of acceleration, or it is a basic law in mechanics, which tells us that there is the direct relationship between the net force and the acceleration, but the relationship between acceleration and the mass of an object is inverse. Mathematically, we can write the sum of all the forces acting on the object is equals to the product of mass and acceleration, or we can also say that the net force is equals to the rate of change of linear momentum. On the third law, which says that for every action force, there is an equal and opposite reaction force. Students, with these key concepts and examples, we come to the end of our lesson today. So, thank you for your attention and goodbye.